Hey everyone, welcome back to another video. So today we'll be solving questions on IGCSE Chemistry, the particular nature of matter. So I'll be solving these questions along with you. I'm doing them for the first time as well, and then we'll check them on the mark scheme. Okay, let's start. Question 1. In which changes do the particles move further apart? So we know that the particles move further apart when they are a gas or a liquid. So we'll have to look for changes where it will go from a solid to a liquid. And since there are two of these options there, we have to look for a solid to a liquid and then from liquid to a gas. Okay, if you guys haven't watched my video yet on this chapter, first go watch that video and then come and look at this video. Okay, so we can see that Z represents from a solid to a liquid. Okay, so I think Z is one of them. Okay, so which one has Z? B and D. Okay, but we need one more. So which one? From a liquid to a gas. Okay, we have Y there. Great. Do we have Y and Z? D, yes, we have Y and Z. So our answer should be D. Moving on. Diagrams X, Y, and Z represent the three states of matter. Which changes occurred which change occurs during boiling? Okay, so X is our solid, Y is our liquid, and Z is our gas. So we know that boiling occurs from a liquid to a gas. So that means it will be from Y to Z. Do we have an option like that? Y to Z, option B. Let's go with option B then. What change of state takes place during evaporations? Again, evaporations and boiling are the same thing except with a few differences. So that will be from a liquid to a gas. Do we have an option like that? Yes, we do. B. So let's take that. In which process do particles move closer together but remain in motion? Well, I think that will be from a gas to a liquid, and if gas to a liquid is what? Condensation. So let's go with A, condensation. Okay, question 5. The changes that occur when a substance changes states are given below. The process W, X, Y, or Z is occurring in the following four situations. Butter melts on a warm day. Water condenses on a cold surface. The volume of liquid ethanol in an open beaker reduces. Ice forms inside a freezer. Okay, so butter melts on a warm day. That is melting. That is from a solid to a liquid. So from a solid to a liquid is W. So a 1 becomes W. 1. Okay, so we have A and B. Now let's see which other two we can get. Water condenses on a cold surface, so that is from a gas to a liquid, so that is uh, Y. Okay, so we have an option like that, option B, W, and Y. But then let's look at another one. The volume of liquid ethanol in an open beaker reduces. Okay, that will be X, yes. And then ice forms inside a freezer, that's freezing liquid to a solid. That's Z, yes. So I think it's B. Let's move on. Wait, sorry, let me take it properly. E. The diagram shows a sugar lump in a cup of tea. Which two processes must happen to spread the sugar evenly in the tea? Okay, so first process I think should be dissolving. So the two processes that will be here will be dissolving and diffusion. Okay, so the first process, should it be dissolving or diffusion or melting? Well, I think the first process should be diffusion and then dissolving. I'm not really sure for this one, but then let's go with A. Wait, let's look over it again. First, the sugar molecules. Wait, no. Yes, the sugar molecules will first have to dissolve before they will diffuse. So I think let's go with B. So dissolving and then diffusion. A sugar cube is dropped into a hot cup of tea. The tea is not stirred. Which statement explain why the tea becomes sweet? Okay, let's look at one. The heated water molecules penetrated the sugar cube. The hot tea causes the sugar to melt. The sugar cube dissolves as its molecules diffuse. The sugar molecules get hot and evaporate. Well, the only one that sounds logical to me is C. course, as we looked over here, there's the same question but then with a diagram. The sugar molecule, without being stirred, first it would diffuse and then first it would dissolve and then diffuse. And it's mentioned here as well, dissolve and then diffuse. So I think it's C. If you guys have a different answer, let me know in the comments. Okay. Next question. A crystal of purple potassium manganate was added to each of the beakers shown in the diagram. So we have hot water and cold water. One beaker contains hot water and the other contains cold water. In both beakers, the purple color of the potassium manganate spreads out, which results in explanations are correct. Color spreads faster in cold water. Color spreads faster in cold water. Color spreads faster in hot water. So I think color spreads faster in hot water. So C or D. Let's look at the explanation. Particles move faster at a higher temperature, or particles move slower at a higher temperature. Well, particles move move faster at a higher temperature. So I think it should be C. Moving on. Question 9. Which statement is an example of diffusion? The keyword is diffusion. A kitchen towel soaks up some spilled milk? Nope. Ice cream melts in a warm day? Nope. Pollen from flowers is blown by the wind? Nope. The smell of cooking spreads through a house? Yep. So it's D. 10. A few drops of perfume were spilled on the floor. A few minutes later, the perfume could be smelled by a few meters away. Which two processes have taken place? So, just like the smell of cooking, this time we have perfume. So, diffusion will be part. So, we have two points over here, diffusion and diffusion. So, which one is it, B or D? Well, first the perfume will have to evaporate and then it will diffuse. So I think it should be D. Let's move on to the next question. 11. The diagram shows the results of dropping a purple crystal into water. Which processes take place in this experiment? Is this a chemical reaction? Well, I think it's a physical reaction. Oh, no, sorry. I'm not sure if it's a chemical reaction, so let's leave this out. Is it diffusing? Yes. Is it dissolving? Yes. So I think it's either A or D, but then I think it's D, so let's go with D. Two gas jars each contain a different gas. The gas jars are connected and the cover slips are removed. The diagram shows what happens to the particles of the gases. Okay, so this is one of the gas and this is one of the gas, and a cover slips is covering both of them. Once it is removed, we can see that this ones go down and this ones go up. So they're asking, come so the question here is, which processes has occurred? Chemical reaction? No. Condensation? No. Diffusion? Yes, it's diffusion. They're randomly moving. That's why it's diffusion. Question 13. A liquid is heated until it boils. Which results show that the liquid in the test tube is pure water? Condensation forms at the top of the test tube. Steam is produced. The thermometer reads 100 degrees Celsius. There's nothing left behind in the test tube. Okay, they say pure water, and we all know that the boiling point for water is 100 degrees Celsius. So, if the thermometer reads 100 degrees Celsius, that means it is correct that the test tube contains pure water. Moving on. An attempt was made to compress a gas on a solid using the apparatus shown. Which substance would be compressed and what is the reason for this? A. A gas or solid? Okay, so I think it's a gas, but we have two options as gases. Let's look at the reasons. The gas particles are close together. No, this is only in solids and liquids. The gas particles are further apart. The gas particles are far apart. Yes, this makes sense. I think it's B. Let's move on. Question 15. A gas jar of bromine vapor and a gas jar of air are set up as shown in diagram 1. The glass slide is removed. Diagram 2 shows the appearance of the gas jars after 1 hour. Okay, which statements explain why the bromine and air mix together? Bromine is denser than air. Bromine is lighter than air. Bromine molecules move upwards and molecules in air move downwards. Molecules in bromine and air move randomly. Okay, so this question 15 is similar to this question we just saw. Let me just scroll back. Except that they have given us a name for this and this. So basically, since it was diffusion, it's their random movement. Let's look at any. Okay, molecules in bromine and air move randomly means diffusing, so it should be D. The diagram shows a cup of tea, which would describe the water particles in the air above the cup. Okay, a lot of students make a mistake when reading the question. So we have to note above the cup compared with the water particles in the cup. Okay, so the water particles outside, I think, yes, they are moving faster, but then they are not closer together. Let's see if there's an option like that. B. So let's go with B. What are the processes W, X, Y, and Z in the following diagram? So we know that a solid to a liquid is melting. Okay, we have melting and melting. Then X, liquid to a gas is boiling. So we have boiling. A gas to, okay, solid from a liquid to a solid is freezing, and a gas to a liquid is condensation. C meets all the requirements, so let's go with C. 18. Particles moving very slowly from an area of high concentration to an area of low concentration. Which process is being described here? A liquid being frozen? No. A solid melting? No. A substance diffusing through a liquid? A substance diffusing through the air? So they are both diffusing over here, but then they say the key word over here is very slowly. When substance is diffusing through the air, it diffuses fast. But then when it's diffusing through a liquid, it diffuses very slowly. So over here, it should be C. So that is the key term we have to look. First, read the question carefully and then answer. Okay. Which diagram shows the process of diffusion? At first, okay, let's see. Yes, these two are separate and then they join together. Yes. The rest of them don't look like diffusion to me. Let's go with C. In which substance are the particles close together and closely moving past each other? Okay, so air, no, I don't think so. Ice, no. Steam is basically gas, and air is also gas. This is solid, and the thing they're asking here are the requirements for liquid, and we know water is a liquid. So let's go with D. The diagram shows the arrangement of particles in three different physical states of substance X. Which particles about the physical states of substance X is correct? Okay, particles in state 1 vibrates about fixed positions. No, state 1 is a liquid, and we know that particles only vibrate in solids, and solids at state 3. So 1 is not correct. State 1 changes to state 2 by diffusion. No, that is not true. State 2 changes to state 3 by condensation. That is also not correct. The substance in stage 3 has a fixed volume. Yes, that is correct, since stage 3 is a solid and all solids have a fixed volume. I believe it should be D. Question 22. In which changes do the particles move further apart? Yes. Okay, so we know it from a solid to a liquid and from a liquid to a gas. So I think it will be Z and Y. I think this question was repeated. So Z and Y, D. Moving on to the last two questions. Okay. Aqueous lead nitrate and aqueous potassium iodide are added to a dish containing water, as shown. Aqueous lead nitrate, yellow precipitate, aqueous potassium iodide. A yellow precipitate forms after a few minutes. Which processes occur before the precipitate occurs? Diffusion, distillation, fermentation, or filtration? I strongly believe it should be diffusion, because this diffuses from here, area of high concentration to area of low concentration, area of high concentration to area of low concentration, and when they mix, this yellow precipitate is formed. Give me a second. Yeah, let's continue. Question 24, last but not the least. The diagram shows how the molecules in the exhaust gas diffuse into the air. Which statement describes what happens to these molecules next? The molecules fall to the ground because they are heavier than gas molecules? No, this is not true. They diffuse in an upward movement. No, they diffuse upwards, not downwards, and then to rest there. The molecules go back together as they cool. They don't go back inside after they cool. The molecules spread further into the yes. This makes sense. The molecules stay where they are. No, they don't stay where they are. They are diffusing outwards. So I think it should be C. Okay, now let's check our answers with the mark scheme I have here. Okay, so question one, DBBA. DB, sorry, D. Okay, let's change our color. So, yeah, D, B, B, A for correct. Let's go. Then we have B, B, C, C. Yeah, B, B, C, and C. Well, we got them correct so far. Let's see. Then D, 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 C. D D D C D D D C. Let's go. Then we have C B D B. Okay. Sorry. C C B D and B. Okay. Next up we have what question? 17. Okay. 17 is C C C D. Okay. So C C C C C and then D. Okay, last four questions. D D A C. D D D A and C. Okay, that was great. We got all the questions correct. I hope this video helped. Make sure to like, share, and subscribe. Till then, see you in the next video. Bye bye.